And so we understand, but I'm sure you'll be just fine. We do encourage you to follow along with your copy of the International Residential Code and other applicable ordinances. Copies of the I-codes can be obtained at the ICC website at iccsafe.org. I also recommend you have a copy of the 2020 National Electric Code, NFPA 70, because there are going to be some times we're going to reference directly to NFPA 70. And so it'd be handy to have your code book available and tabbed up and ready to go, especially if you're going to be planning to take an exam anytime soon. When the inspector arrives to conduct the footing inspection, they also may be looking at the site for the porta-john being placed on site, that the site address is properly posted, that the permit card is posted as required by the code unless exempted by the jurisdiction. They may also be looking at soil erosion management, setbacks, and other requirements of the local jurisdiction. Footings and foundation systems. In order to properly support the loads of a building, footing design must address not only the size of the footing, but factors such as the condition and characteristics of the soil, the footing depth, slope, and reinforcing. For other than engineered soil conditions, footings must bear on undisturbed ground and extend below the frost depth to provide a stable foundation. In addition, exterior footings require excavation to at least 12 inches below the undisturbed soil. Vegetation, wood, debris, loose or frozen soil, and any other detrimental materials are removed prior to placing concrete. To prevent sliding and to adequately transfer loads to the soil, the code limits the slope at the bottom of the footing to a maximum 1 unit vertical and 10 units horizontal, or 10% slope. Transitions that would result in greater slopes must be achieved through stepping of the footings. Soil bearing capacity and the average gravity loads determine the footing size. As the load bearing capacity of the soil decreases, footing sizes increase to distribute the load to a greater area. The IRC prescribes the width of continuous footings based on the number of stories supported, the method of construction, the type of foundation, be it basement, crawl space, or slab on grade, the snow load, and the load-bearing values of the soil. The placement of buildings and structures on or adjacent to slopes steeper than 1 unit vertical and 3 units horizontal shall conform to sections R403 1.7.1 through R403 1.7.4. Where slopes are steeper than 33.3%, which is 4 inches per foot, foundations must be located a sufficient distance away from the slope to protect the integrity of the structure and provide adequate lateral support to the footing. The clearance distance is based on the height of the slope. For a building located adjacent to the top of the slope, the descending area, the minimum distance is the height divided by 3, but does not need to exceed 40 feet. For a building located adjacent to the bottom of the slope, the ascending area, the minimum clearance is the height divided by 2, but does not need to exceed 15 feet. The code gives the building official the authority to approve alternate setbacks with lesser distances to slopes based on design by a qualified engineer, taking all site conditions into consideration. For the most part, the IRC permits footings without reinforcement in seismic design categories A, B, and C for single-family dwellings. If rebar is used in the footing, it must be installed correctly. Wooden grade stakes, red brick chairs, inadequate concrete coverage, and improper splice lap ties are not allowed. Soil tests may also be required and will be discussed further. Vapor barriers are required when the footing is part of a slab on grade installation. Where rebar is provided in the system and the system is not otherwise exempt, then the rebar must be part of the grounding system for the building. Again, for the most part, the IRC permits footings without reinforcement in seismic design categories A, B, and C for single-family dwellings. Including rebar in a concrete footing means that you can reduce the risk of concrete being pushed and pulled apart or cracking from ground force pressure. Knowing this, it is generally a good idea to use rebar in footings for any structure. However, it is not required in many cases by the code. The designer or builder must carefully consider soil properties not only for adequate support of the foundation, but also for stability to prevent future damage to the structure. Based on experience and known local soil conditions, the building official will often permit design based on presumptive load-bearing values without soil testing or a geotechnical report. Where available data indicates that the soils may not be suitable for the foundation design, the building official is authorized to require a geotechnical evaluation and report prepared by an approved agency or registered design professional. Expansive, compressible, or shifting soils have the potential to damage the structure. In addition to organic materials, certain inorganic clays and silts are highly expansive. Such soils expand when wet and contract as they dry, exerting significant pressure against the footing and foundation and thereby causing shifting or differential settlement that could result in structural failure. Expansive soil conditions require an engineered foundation design in accordance with the International Building Code. In some cases, it may be possible to remove unsuitable shifting or compressible soils from the building site and replace them with approved fill to stabilize the soil below and around the foundations. Under these conditions, the IRC permits a prescriptive foundation design without a full geotechnical evaluation. Slab on grade inspections. Proper operation of the sanitary drainage system depends on adequate pipe size of approved materials, appropriate slope and support, transition fittings suitable for the location, adequate cleanouts, and proper venting. The code requires specific approved methods for joining and connecting drainage piping to provide a gas-type system with optimal flow. Cast iron pipe is typically connected with compression gasket joints or mechanical couplings. PVC DWV pipe joints are solvent cemented. These two different piping materials may be joined together with approved mechanical couplings. The code prohibits a reduction in size in the direction of flow. Fittings for change in direction must be suitable for the installation to maintain acceptable flow and reduce the possibility of stoppage. For example, sanitary tees are not permitted for vertical to horizontal or horizontal to horizontal transitions. Such changes in direction are commonly accomplished with a Y, a combination Y and 1/8 bend, or long sweep fittings. The general rule for minimum pipe slope is a 1/4 inch vertical drop for each 12 inches of horizontal run, a 2% slope. A minimum slope of 1/8 inch per foot, or 1%, is permitted for pipe sizes 3 inches or larger. In our area, we typically see plumbing systems under slab tested with a 10-foot head pressure. Code provisions recently changed to allow a minimum of 5 foot. It is important to remember that this is a water test. For PVC, you cannot use air pressure. There are certain hazards inherent to that type application. Please keep this in mind. Also keep in mind that the piping through the foundation walls or under the footings should be sleeved with a sleeve at least 2 pipe sizes larger than the pipe passing through it. To review, the DWV system shall be tested with a water head pressure test for at least 15 minutes. The water test is required for DWV PVC systems. For cast iron or other products, you may use other methods as approved by the manufacturer. Keep in mind that air is not permitted to be used for a testing mechanism for the underslab PVC DWV system. Other plumbing under slab issues to consider include that water distribution piping shall not be in direct contact with concrete. A sleeve is required where the piping passes through or under the footings. Grade shall comply with the International Plumbing Code and the IRC applicable provisions. No sanitary tees on a horizontal plane, and all fittings must comply with IRC P3005.1. Solvent, cement, and purple primer, there are special exceptions on these, which we will discuss later. Other under-slab rough-in considerations may include rough-in for radon in areas where radon protection means are required. Also, certain termite treatment requirements, depending on the jurisdiction and area needs. To continue with our slab on grade inspections, bearing points for columns and bearing walls should be clearly defined at the inspection, including footings for porches, decks, patios that support loads above. The slab on grade within the building envelope and garages require a minimum 6 mil vapor barrier placed over 4-inch thick base course of gravel or stone under slab on grade. Slabs must be a minimum 3.5-inch thick and capable of carrying all loads. R506.2.3 vapor retarder. 6 mil with joint slab not less than 6 inches. 100% coverage to separate concrete from earth. Seal all penetrations of the vapor retarder. Again, garage floors must be sloped to facilitate movement of liquids. This is R309.1. I want to speak a few moments concerning vapor retarders. First, let's look at the code. R506.2.3 vapor retarder. A 6 mil polyethylene or approved vapor retarder with joints lapped not less than 6 inches shall be placed between the concrete floor slab and the base course or the prepared subgrade where no base course exists. On a recent upstate South Carolina slab on grade inspection, the following was encountered. As you can see from the photographs, we have a perimeter footing with number 4 rebar. We also have interior footings to carry load bearing above. However, if you will notice immediately in the photographs, the vapor barrier, a 6 mil vapor barrier or vapor retarder, does not provide full coverage of the area. The code, while it does not say 100% coverage, it says that the vapor barrier shall be provided to provide separation between the earth and the concrete slab. This is an issue that becomes very, very difficult for people laying floors. With the progress of house building in the upstate of South Carolina that we are seeing, where homes such as these in this subdivision are completed in less than 90 days, the concrete is not even fully cured at that point. So floor covering becomes an issue, but more importantly, we have a code issue. The code, while it does not say 100% coverage with a vapor retarder, it still says it provides separation. There are various schools of thought on this, and we'll expand on those in a few minutes. In the few minutes that we can spend on this subject, I'd like to touch upon the importance of having 100% coverage of a vapor retarder vapor barrier. In this picture, what we're going to see is we're going to see that we have a vapor barrier that comes along separating the earth from the concrete. And typically what we see in the upstate of South Carolina is this vapor barrier will turn down to the footing and it stops right here. What this does, it allows all this concrete to have direct, here and here, all this concrete to have direct contact with the earth. This speeds up the process of a capillary motion of moisture to wick through brick and come up into the flooring. The issue we're going to run into is if we had a wood flooring, laminate, or even a carpet flooring, we're going to get moisture content values greater at the perimeter of the home than what we would at the interior sections. The code does not have language that says specifically 100% coverage. It says coverage. It doesn't say 10% coverage. It doesn't say 50% coverage. It doesn't say 100% coverage. My interpretation, and this is my interpretation, is that we should have 100% separation of earth from the concrete. That means complete separation. This means we have the full area covered with a 6 mil poly. That all of the 6 mil poly is properly lapped and it is sealed. All penetrations are sealed. This prevents or at least lessens the action of the wicking action of moisture through the concrete to the floor above. Seams should be sealed and all penetrations protected. With this installation, we have vapor barrier that goes down, catches the footing, comes back up. It actually overlaps the boards, so when after the concrete's poured and the forms are cut, they'll cut this excess plastic off, and we have created a very effective barrier of earth to concrete. Depending on climatic conditions, significant amounts of condensation can accumulate in enclosed crawl spaces, causing decay and other damage to the structure. The code requires ventilation openings through the foundation or exterior walls in the prescribed size and location to circulate air and dissipate condensation. An alternative method permits a crawl space without foundation openings when equipped with mechanical exhaust ventilation or connection to the conditioned air supply of the dwelling. In this case, the code requires installation of the exterior walls and a vapor retarder on the ground and sealed to the enclosing foundation wall. The IRC requires access to the underfloor space. Concerning the foundation and crawl space, backfill should not be placed against the wall until the wall has sufficient strength, anchorage, and bracing. Waterproofing and foundation drainage, French drain, should be installed at this time. Foundation drainage shall positively slope to daylight as site conditions warrant. Exterior waterproofing and drainage systems are required on all basements, storage spaces, habitable spaces, and when the inside grade of the crawl space is lower than the finished outside grade. Repeat, and when the inside grade of the crawl space is lower than the finished outside grade. R606.4.3 Masonry walls shall be solid units or grouted at a change in thickness. Foundation crawl space considerations continued. Underfloor spaces containing mechanical equipment shall be provided with an unobstructed passageway large enough to remove the largest appliance, but not less than 30 inches high by 22 inches wide and no more than 20 feet in length. This is found in M1305.1.3 of the 2018 IRC. The minimum net area of crawl space ventilation openings shall not be less than 1 square foot for each 150 square feet of underfloor space area. One opening shall be within 3 feet of each corner. If ground is covered with an approved vapor retarder, the ventilation openings can be reduced to 1 square foot for each 1,500 square feet of underfloor space. Please note that the standard 8-inch by 16-inch foundation vent does not equal 1 square foot of ventilation. 8-inch CMU piers cannot exceed 80 inches in height. 8-inch CMU piers over 32 inches must be filled solid and capped. Hollow piers shall be capped with 4 inches of solid masonry or concrete, or shall have the top course filled with concrete or grout. Masonry walls shall be laterally supported per R606.6.4. And concerning flashing and weep holes must be installed correctly. Drilling weep holes is not an acceptable practice. So let's talk a little bit more about these 8 by 16 foundation vents. The one you see in the picture is pretty much typical. You get one of the big box type stores. The 8 by 16 foundation vent that you're looking at doesn't gonna quite comply with the code. If you look on the vent real close, you'll find somewhere on there it'll actually give you what the net free ventilation area openings is, and it'll give you the total on it. And you're going to find out it's going to probably end up being between 45 to 65 square inches. So of course it's not going to comply with the code. So look at these very closely, because what they're going to do is they're going to cause you to have to put in more foundation vents. Because building codes such as the IRC generally require that a net free ventilation opening for every crawl space meet certain requirements, which is going to be 12 by 12, which is 144 square inches. you're going to find out you're going to have to use a lot more of these foundation vents. A good example, if your vent provides roughly 50 square inches, it's going to take 3 of these vents to equal 1 square foot of code compliant ventilation. So look at these very closely. Usually again, the square inches of net free ventilation opening is usually inscribed somewhere, stamped on the device. And to review 606.6.4 masonry walls laterally supported. This is common sense stuff. I mean, when you're standing up these walls, you've got to provide support. You can't just rely on what little bit of rebar they get put in there every 4 to 8 feet. So you have to have support for these things until they completely cure to a safe degree. And don't forget that weep holes are critical to a brick veneer type finish on a house. Remember that brick is a siding product, but it has to be able to get rid of any moisture it might trap in the interior space. And drilling a weep hole after the fact is just not acceptable. Flashings and weep holes are critical to a good, safe installation. Okay, you've made it this far. Thank you for your attention. I ask please that you buy me a cup of coffee. Like and subscribe on YouTube so that we can continue these videos for other folks. And if you'd like a copy of the residential inspection checklist, or maybe a little quiz that we have written up based on the residential code, you can get that by sending me an email to the email address you see here, which is dolesmichael@gmail.com. So please like, subscribe, support this work. If you would like to have Doles Enterprises come out and do a presentation in person to your group, we can certainly discuss that. Just depends on logistics and a few other things, but we'll do whatever we can. So visit our other videos, and we appreciate everything that you're doing, and we appreciate your attention. Mike Doles again. Just wanted to let you know that we're concluding this session, and I ask you to please go to the next session and take your time. Please like and subscribe to this YouTube channel. This is how we're able to offer this free. And also anything you can do to buy me a cup of coffee or any other way you can do to help support this, we certainly do appreciate it. So just proceed to the next session. Take it at your own pace. Don't become overwhelmed. You're not going to know it all to begin with if you're just now starting out in this profession as a building inspector.